Welcome to Hancock's VMware Half Hour. And welcome back to the Hancock's VMware Half Hour. Okay, well, in today's video, we're going to go back to the MINISFORUM MS-A2 that we're obsessed with here at Hancock's VMware Half Hour. And we're going to move on. And we're going to start configuring it. If you've been watching this channel, you know that we've had a little look at Windows 11 running on it. We've done Windows Server 2025 and we set up Hyper-V, and we used it to migrate some virtual machines off VMware vSphere ESXi. And we've had a little look at, had a little bit of fun with it, playing Doom, Legacy Doom from 1993, and we had a little bit of fun playing Doom The Dark Ages from 2025 using an external RTX 3090 using the Oculink card and the MINISFORUM eGPU external graphics card dock thing. Anyway, so we're going to get back into a bit of VMware now. But the first thing that I wanted to do, and I wanted to experiment with, and I did do a couple of videos, which I'm still on the fence as whether or not I'm going to tag them to the end of this one or whether I'm just going to discard them, really, to be honest with you. I wasn't really happy with the output of the cam that I had that showed the focus of me installing the U.2 NVMe SSD in the unit, so I scrapped them. And then I also found out basically that one of the U.2 devices, or in fact actually quite a few of the U.2 devices that we've got from Samsung potentially are counterfeit or fake. Yes, it had to happen sooner or later that we were going to come across fake counterfeit SSDs or NVMe devices or U.2 devices. So these SSDs really, they don't really look any different. I'll just hold that up. There, this one's probably a fake one that you're looking at. So they don't really look any different to a SATA SSD, other than the fact that the protocol that transfers and talks to these devices is NVMe. So these are PCIe Gen 4 devices that effectively hang off the PCIe bus using NVMe. So they're just a slightly different format. U.2 is just a slightly different format than the conventional M.2 stick type format that we regularly see, things like that on the P310, although that's quite a short one, or ones that are commonly this sort of kind of size as well. That's got a heatsink on it, so I think that's a Samsung device, and that's an NVMe controller that plugs into the motherboard. So the reason for using a U.2 device is that, first of all, they are enterprise SSDs, so they're not consumer and they're not even prosumer. They're enterprise SSDs, so they've got longer warranties, the performance is better, the wear is better, etc., etc. And of course, the MS-A2, the MINISFORUM MS-A2, can accommodate a single U.2 device. And if you buy one of the devices, you will find in the little box that I might have mentioned in one of the past videos that we did, that in the little box inside comes a lovely little U.2 to NVMe carrier. Now, it does take up one of the NVMe slots. It takes up the outer NVMe slot. So I thought, in this video, I'm going to show you what we're going to do with our NVMe device. Now, one of the real benefits of using an enterprise class NVMe device is it supports something called namespaces. Now, I've been trying to think of a way really to explain what namespaces are, if you don't know what the hell I'm talking about. And a namespace is a method where we can chop up the NVMe device and create a series of devices. So it's a little bit different to think some people actually basically think these are partitions. No, they operate at device level. So these are more like a logical unit number. They're more like a LUN than a partition. And it actually allows us to present effectively 3 NVMe devices to the operating system rather than conventionally 1. Like certainly we can take a 1 terabyte NVMe disk and we can chop that up into 3 formatted partitions, but those are 3 partitions. And what I want to start doing next is I actually want to start looking at using the device here in the lab for VCF9 later and for ESXi. And I actually basically want to present 3 devices. Now, okay, I could have done it the cheap way. I could have used 3 NVMe sticks in our 3 NVMe slots. That would have given me 3 devices. But now I have the ability to present as many devices as I like to our operating system by chopping up our NVMe device. That still gives me 2 NVMe slots free that I can put 2 traditional NVMe slots in. And of course, you may remember that we actually basically converted the Wi-Fi and the Bluetooth module using an A and E key, and we put in the 310. So it's all about maximum storage. So in today, we're going to get jiggy with it, and we're going to start looking at NVMe namespaces. Now, I do apologize in advance. There's a bit of maths involved in this, and my head's been hurting trying to get the values right. And in the end, I actually basically worked out, and in fact, it's decimalized these, not byte counts in 1024. They're decimalized. And there's going to be a lot of SSH type bash shell commands. So I apologize in advance. So let's get into this. And let's just turn off that. And there you go. We are currently booted using Ubuntu 24.04 LTS server on our MS-A2. We've installed the NVMe CLI package. So we've basically just done an apt-get space install NVMe-CLI. And I tell you what I'm going to do. This document that I've been working off, that I've been crafting, I'll upload that to GitHub, and I'll put a link in the YouTube description so you can have a little look at the commands, because there are a lot of NVMe commands that I'm going to basically be using. So the first thing you want to do, if you've never used the NVMe CLI, is just type NVMe space, if I can type NVMe list. Now, word of warning, you probably certainly want to basically escalate your permissions to root, because the NVMe command, some things it will work as root and some things it won't, or vice versa. If you're non-privileged, some things will execute, but sometimes it actually basically needs sudo permissions to do stuff. So therefore, the best thing to do is just to escalate to root, or sudo to root at the very start, and then you don't have to keep putting the word sudo in front. Anyway, so let's get back to this. So if I do NVMe list, then that will show me all the NVMe devices that are currently attached to the bus. Now, if we have a little look at dev/NVE1N1 for the moment, then that's our this boy here, or girl. That's our P310, that's our PCE Gen 4 NVMe 2230 M.2 SSD. So we're not worried about that one, and I must realize actually not to delete that one, because otherwise I'll lose the Windows Server 2025 operating system on it. So the one that we want to be looking at here is dev/NVMe0N1, which is our Samsung MZQL23T8HCLS-00A07, and it's a 3.84 terabyte NVMe. Now, in fact, actually, its friendly name is called a Samsung PM9A3 2.5 inch. And word of caution, there are some fake ones in the world of these, so be careful where you obtain them from. And even if you do obtain them from the right places, you also end up with fake ones as well. But we won't say who at the moment. Anyway, so the very first thing that you actually want to do, there's a command called, there's a function called id-ctrl. Now that effectively looks at the controller on your NVMe device. So if I basically do, again, sudo's already there, sudo NVMe id space control /dev NVMe 0 and hit enter, then you get an awful lot of stuff back about your particular device. Now there are some key variables that you want to be looking at here, really, to be honest. Like obviously serial number and manufacturer name and firmware. Okay, fair enough. But there are a couple of other ones really that you need to have a little look at. Now the first one, really, I'm going to use grep here to make it a little bit easier. The first one is tnvmcap. That gives you a total capacity of the media, the device, and then unvmcap shows you the space that's currently occupied. Now the reason I'm showing you these is because you can get in an awful mess, believe you me, with creating namespaces, deleting namespaces, not deleting namespaces, and you'll wonder why your capacity is not correct because you've not removed the namespace. Now, another thing, when you start removing namespaces, and if I just go back again and have a little look at that NVMe list, when you first get the device, you've got a single namespace, as you can see there, which basically says namespace 1, and that namespace 1 is actually occupying the entire capacity of that device. The moment that you remove that namespace, then you've got a completely blank NVMe disk. It will no longer appear in this NVMe list anymore, and there's no method, there's no reset function to put it back to defaults. You've actually got to create those namespaces again once you've actually deleted them. So if you're getting a mess like I've done, whereby you delete the namespace, it disappears, and you think to yourself, oh my god, I balked it. All you've got to do realistically is look at the total capacity, and you can recreate that single namespace. Okay, so moving on, what I want to do with this device, I want to split it into 3 devices, and I've decided for what I want to do here in the lab, I want to create a 800 gig partition. Sorry, shoot myself. I want to create an 800 gig namespace, a device, an 800 gig device. So that's my first NVMe device, will be 800 gig. I want to create a 1 terabyte NVMe device, and I want to create a 2 terabyte NVMe device. So effectively, I'll end up with 3 different devices at 800, 1 terabyte, and 2 terabyte. And the reason why I'm going to install ESXi 8 and 9, and a shout out to the person that turned around and said, yeah, Doom is all very cool, but does the MS-A2 run ESXi or VMware vSphere? So yes, it does. I already know that. But next couple of videos will be on installing ESXi 8 and ESXi 9. Am I going to use that 800 gig NVMe device to actually create my installation? And then I'm going to leave the other 2 NVMe devices for vSAN later on as a capacity and also cache tier. So that's why I've structured and had a little think about what I want to do in the future. So I've got a quick way of speeding this up so that you're not watching me typing loads. So I could have just done one big script with this, but then you wouldn't have really seen much. So all I've done effectively really is just create some variables, ns1 underscore bytes, ns2 underscore bytes, and ns3 underscore bytes. And of course, these are decimalized, which has been giving me a bit of a headache. So I'm just going to specify those as my NVMe devices. So ns1, ns2, and ns3. Followed by enter. Now we need to basically ensure that these fall on a 512 byte and they are aligned correctly. So again, some little calculations there. ns1 underscore blocks aligned equals, don't write this down, I'll put them on GitHub so that you can basically see what I've been doing here with the NVMe namespaces, and I'll also basically create a link to the NVMe's organization documentation on namespaces as well. So the next thing I'm going to do before I cut and paste this, I'm going to do a sudo space NVMe space create-ns. So that's create namespace /dev /NVMe. Oh, in fact, actually, there's one thing that I've got to do that I have completely forgotten, of course, and that's I've got to delete the existing namespace that's actually on the disk. Because if I actually basically try and create namespace 1 again, namespace 2 again, namespace 3, of course, these aren't going to work. And there's another thing that I've also forgotten to show you as well. My bad. I jumped when we were basically looking at the vcap information. So let's just go back. And there's another command that you need to look at, or another variable that you need to look at. And effectively, we're using the id-ctrl command again, dev /NVMe, and I'm grepping for NN. Now, NN shows how many namespaces your device can support. So we can actually chop up this 3.84 terabytes into 32 namespaces. Some devices have 64, some have 128, and some have 32. If you only have, we'll have a little look to see what it actually basically says about our other device, 1. So our namespace for our crucial device, this one, only has 1 namespace. So therefore, it can only support 1 NVMe device of the total capacity of the NVMe device. Okay, so my apologies. Just thought I'd make that clear that before you actually really want to start creating namespaces, deleting namespaces, you really want to check first of all that the capacity is grepping for the vmcap variable, and also basically having a little look at that NN variable. Anyway, so I'm just going to create I'm just going to use a mechanism to detach the namespace. So I'm going to use sudo namespace. Okay, so I'm using sudo NVMe space detach -ns /dev /NVMe 0 -n1 -c 0x6. Now 0x6 is the controller ID, and we can find the controller ID by using the id-ctrl variable, and we can grep for the command cntlid. So there we go, there's our controller number. And we need the controller number because once we've created the namespace, we have to attach the namespace to the controller. So I'm now going to delete that namespace. There we go. Success deleted. So if I go back and do the NVMe list, what I was saying to you before, now you can see now that it's completely gone, but we can still use our sudo NVMe id-ctrl dav NVMe 0. There we go. And if we have a little look at the capacity, so there's our total capacity and there's our unused capacity. So we can actually basically see now that that effectively is all the namespaces are removed and they don't exist. So now I can move on and I can create our namespaces. So again, I'm using sudo space NVMe space create-ns /dev /NVMe 0 -s, our first block aligned, space -c, followed by our ns1 block aligned, and then we want a --flbas equals 0. Now that's the actual block size that you want to create. So we want to create a 512k block size. If we wanted to use a 4k block size, we could use flbas equals 1. So I'm just going to cut and paste all those in, and hopefully there we go. You can see that we've got namespace 1, namespace 2 and namespace 3 created. Now again, if I actually have a look at NVMe list, we still can't see any devices or nodes as it calls them, because they've not actually been attached to the controller, and we have to attach each namespace to the controller. And again, using the command sudo space NVMe space id -control ctrl space dev /NVMe 0, and then grepping for cntlid, we get 0x6, because we need to have the controller ID specified to attach our namespace. So again, if I basically just cut and paste them, so I'm going to attach my namespaces now. Sudo space NVMe space attach -ns space /dev NVMe 0 space -n1 first namespace -c, followed by our controller ID 0x6, and I'm going to hit enter. Now that's going to attach all our namespaces now to the controller. We've got success. And now if I actually basically have a little look at our NVMe list, can you now see, as far as Ubuntu is concerned, we've got 3 separate devices there: NVMe 0N1, NVMe 0N2, NVMe 0N3, and now they are all reported as namespace 1 is 800 gig, namespace 2 is 1000 gig, 1 terabyte, and 0x3 is 2 terabytes. Now, okay, we've got 40 gig that's gone amiss there, but I have been experimenting in trying to get near enough where I wanted to. And then finally, we need to format those areas as well on the disk. So again, that's sudo space NVMe space format dev /NVMe 0N1 space --lbaf equals 0, which is basically 512k blocks. So I'm just going to hit enter with that. It's going to sit there for 10 seconds. You can use the --force to override that, but that's it. So there we go. All about namespaces. Namespaces, NVMe namespaces 101. So that's it for this video. If you've liked this video, then please give a thumbs up, like and subscribe. If you've got any questions about NVMe namespaces, because I know that they can be regarded as complicated, but I hope that I've showed you in a simple manner how we can take an enterprise class SSD, something like this, which isn't fake. And the reason why I suspect it's probably fake is because, one, it only supports one namespace. The firmware is a bit dodgy. And the label, in looking at some other devices, also looks a bit different as well. However, at the moment, we've not had confirmation from Samsung Enterprise to check whether or not that these are fake or counterfeit. It has been incredibly difficult to get these validated as to whether or not that they are they are fake or counterfeit. Well, all I can say really is, if the manufacturer is not easily going to be, if the manufacturer cannot work with you to actually provide information and to tell you whether or not that they're fake or counterfeit, then what hope really have we got on the planet? And maybe this is the reason why that they are being manufactured and why they are being faked or counterfeit, because the manufacturers know that Samsung aren't going to respond easily, or at the moment, to, can you actually basically tell us if this serial number is a valid Samsung device? Can you actually basically tell us if this particular firmware is a valid device? Does this look like a fake device for you? So you've been warned. Be a little bit careful about where you obtain your devices. Anyway, I'll get off my soapbox. Anyway, so again, if you've enjoyed this video, then give it a thumbs up. If you don't like this video, then don't like it. But moving on from this, we're going to use this device in our MS-A2 to install ESXi 8, ESXi 9 in the next few videos. And if you've watched this one, and you look at the next ones that we do, then you will see that when we go through the installer at the beginning, our ESXi installer will pick up effectively that we've got 3 devices to choose, and we will be installing ESXi, the operating system, on the first device. Anyway, so I hope you've enjoyed this video. Come back for some more videos at Hancock's VMware Half Hour. My name is Andrew Hancock. So good afternoon and goodbye, and see you again in the next videos. Bye bye now.